The function declaration line dictates how many input arguments are defined for the function and how many output arguments are defined for the function. However, the function may be called with a different number of input and or a different number of output arguments. There are two built-in functions, nargin and nargout, which give very useful information within a function during its execution. Nargin returns the number of input arguments that the function was actually called with, which is not necessarily the same as the number of input arguments in the function declaration line. Similarly, nargout returns the number of output arguments that the function was actually called with. Again, this is not necessarily the same as the number of output arguments in the function declaration line. Having access to these numbers during the execution of the function allows us to write functions whose behavior and output arguments depend on the number of input and or output arguments that it is called with. Let's see some examples. With nargin, suppose we program a mastermind game, and to play it normally we simply call mastermind. But in order for the program to give us hints, we call it with the argument list hints on. Maybe to preload the secret code so that we can learn how to play more effectively, we call it like that. Alternatively, we might be learning about artificial intelligence and supplying a game-playing strategy ourselves. Possibly we want to seed the random code so that we can repeat the game many times with the same random code. Or perhaps we're trying to control the random seed as well as have the hints on. That's some examples where we called mastermind with different numbers of input arguments in order to achieve different behavior. For nargout, the most common one we've already seen is the size command. When we call it with one output argument, the size is returned as a 1 by 2 array. Here it would be the array 4, 5. But if we call it with two output arguments, then the row dimension is in the first output argument and the column dimension is returned separately in the second output argument. So those are some great examples of how nargin and nargout are used to affect the behavior of functions depending on the manner in which they're called. Let's test out our understanding of nargin and the behavior of Matlab when functions are called with fewer input arguments than are defined in the function declaration line. Here's a function called carg with 3 input arguments and 1 output argument on the function declaration line. The first line displays a string with the number of input arguments as obtained from nargin. Next, a conditional checks for the existence of the variable named b1, which is the first input argument. If it doesn't exist, there'll be a display that says b1 does not exist. If it does exist, the next conditional checks if it's empty and properly displays. Finally, if the variable b1 exists and is not empty, then the display indicates that. Imagine that the code repeats with the same conditionals for b2 and then again an identical set of conditionals for b3. Finally, the code executes a whos to see what's in the function instance workspace, then assigns a simple value to the output argument and returns. Now what we'd like to do is think through what happens in the following different function calls. In the first call, carg is called with 0 input arguments. The next one it is called with 1 input argument, then 2 input arguments, 3 input arguments, and finally 4 input arguments. The question that is being resolved here is what are the values of the missing input arguments inside the function? Do they not exist as variables, or do they exist and are empty? So we'll resolve that by simply trying this in Matlab and seeing what is displayed. Let's glance at the carg code. All the cases are given for b1, b2, and b3, so the code looks a little longer than it did on the slides. But the most important thing to notice is the display of the number of input arguments and then the conditionals for each argument, which checks for the existence of the variable, if it does exist, the emptiness of the variable, and finally if it exists and is not empty, gives a display that shows that. We'll run that for b1, b2, and b3 regardless of the value of nargin, and the displays will be informative, illustrating the behavior. Finally at the bottom there's a whos and the output variable is set to 1. Let's try it now and learn what the behavior is. First, with 0 input arguments, as expected, nargin equals 0, and we see that the 3 input arguments do not exist as variables. So in the function, when this is called with 0 input arguments, none of these variables exist, making these expressions all true. b1 does not exist, b2 does not exist, and b3 does not exist. Therefore, we get the displays stating that the variables do not exist. When the whos is run, nothing shows up. There's nothing listed here because there is nothing in the function instance workspace. Let's try this with one input argument. As expected, nargan equals 1. It says that b1 exists as a non-empty variable. It in fact is the double 0. b2 and b3 do not exist, and the whos shows that there is one variable in the function instance workspace. For two input arguments, we're pretty sure we know what we're going to see. Nargan equals 2. b1 and b2 exist as non-empty variables. b3 does not exist as a variable, and the function instance workspace contains two variables, b1 and b2. For three input arguments, nargan equals 3. All variables exist as non-empty variables, and the function instance workspace shows them. Finally, for four input arguments, we get an error. Functions cannot be called with more input arguments than there are in the function declaration line. In this function carg, there are 3 input arguments. That is the maximum number of input arguments in any function call to carg.